Hi everyone! As many of you are still waiting for your Sovol SVU8 3D printers to be delivered, I thought we could take a little break from the main theme of my channel and talk a bit about something different, but super exciting for our DIY projects, laser cutting. This MacPow X5 in particular won't take weeks or months to deliver, as mine arrived basically overnight from geekbuying.com. I have just started exploring the vast possibilities, not so much as an alternative, but more as a complementary technology to 3D printing. This is Gergo, and you're watching Gergo Print 3D, the up-and-coming YouTube channel about my 3D printing adventures and other DIY projects. I've received some feedback lately on audio quality and my accent. While I continue to work on improving both, I suggest enabling the subtitles. I invest a lot of effort into providing high-quality subtitles for all my YouTube videos, which also translate well into other languages. Now, back to our topic at hand. You and I, we all enjoy exploring the world of 3D printing, many of us specifically with Sovol's budget-friendly yet feature-rich printers, from the Sovol SVU6 Plus to the all-new SVU8. But have you thought about looking into laser cutting and engraving? I think laser cutting, much like 3D printing, is another fantastic way to bring our creative ideas to life. Of course, instead of the additive process of printing layer by layer with plastic filament, here we are using a relatively powerful laser to cut or engrave materials like wood, leather, or even some metals. This opens up a whole new realm of possibilities. Imagine making large custom signs, intricate designs on wood, personalized leather items, or engravings on metal objects. All quite different from the colorful plastic we can 3D print. And we can even combine laser cut parts with our 3D printed projects. What drew me into laser cutting was the ability to work with these more natural materials. There's something incredibly refreshing about crafting a beautiful wooden container or a detailed leather coaster. These materials can be sometimes much stronger and durable than PLA or even PETG or ASA, not to mention the material cost of larger items, which can be surprisingly low compared to the filament requirements, which is great for anyone on a budget. So, laser engravers and cutters are not a replacement for 3D printing, but a practical alternative in some cases, like creating large signs much quicker than printing. Now, just like Sovol has been our go-to for 3D printers, geekbuying.com directed my attention to a similarly impressive option for laser cutters. This MacPow X5. The X5 offers an exceptionally large 600 by 600 millimeter build area and a rich feature set, all at a fraction of the price of other brands. As I did my preliminary research on which device to get, the MacPow X5 stood out for its versatility, as it provides most of the features you'd want, and even some more, all in one complete kit just under 500 euros. You'll see in a minute, this includes really everything from a relatively strong 22-watt laser module, an included air assist pump, and the linear rail system, to even the gift honeycomb bed that would otherwise be a separate purchase with other brands. I felt the same excitement as last year when I first heard about the value my first SVU6 Plus or this latest SVO8 offered. I think the MacPow X5 can really complement our Sovo printers beautifully for some projects providing alternative materials, for others combining multiple materials, for example 3D printing connections for laser cut wooden parts. Transitioning from 3D printing to laser cutting was smoother than I expected. Both involve working with digital designs and require a very similar mindset. However, laser cutting also brings its own challenges and rewards, making it a great next step for any 3D printing enthusiast looking to expand their skills. When it comes to hardware, this particular laser engraver uses a combination of linear rails and V-slot wheels, kind of like a mixture of the SVO7 and the SVO8 3D printers. I hope I managed to pique your interest, as I will show you my initial experience with this large-scale laser engraver, from unboxing to assembly, initial software impressions, and a few exciting test projects, which are of course just the tip of the iceberg. I received 2 packages. We will unpack this 440 by 440 honeycomb laser pad a bit later. The device comes disassembled in this 95 by 38 by 14 centimeter box that, according to the shipping company, weighed 6.5 kilograms. That's an A4 size sheet of 3mm plywood sample material on the very top of the package. Everything is securely packed in white laser cut foam, how fitting for a laser cutter. A pretty short 70 centimeter A to B USB cable. The user manual in 6 languages. Safety eyeglasses. Standard EU power cable. And a 24 volt 6 amps power supply with sufficient overcapacity for the 1 amp 22 watt laser module would need. Some more sample materials, a small piece of MDF and perhaps aluminum. 2 of the longer 20 by 40 extrusions which make up the side of the frame along the y-axis. The screws come in 2 bags, and they've mindfully included 1 extra spare of everything. The shorter extrusions are for the sides along the x-axis, 4 sheet metal feet, which will raise the frame about 65 millimeters above the desk. And this is the laser toolhead itself. The diode laser kit combines 4 5.5 watt modules for a total output power of 22 watts in the standard variant and 6 modules for 35 watts in the Pro version. I have the standard variant here, which is already a major step ahead of the 3 watt engraver I had a chance to test earlier in the year. It is behind a protectively stained plexi window, though the use of safety eyewear is still required. According to the listing on geekbuying.com, this module should be capable of both cutting and engraving tougher materials. We will soon see. On the top is the power and air assist tube connections. This focusing bar will help set the correct distance from the surface to the fixed focus optics. The inclusion of the air assist pump in the base package is very welcome. It makes this an even better deal, in my opinion. This saves us both money and hassle looking to make sure we find the compatible pump. See, it will get electric power from the controller box, and it will connect to the gantry using this rubber tube. More on this whole thing later. We get some rubber feet, a full-size Phillips screwdriver, and a brush for cleaning the air assist nozzle over the lens or the honeycomb bed. The next parts are already assembled. The controller box is permanently connected to the gantry using a flexible wire loom in a low friction cable sleeve with reasonably good strain relief on both ends. The 6mm timing belts are part of the Y-axis motion system, and V-slot wheels for the Y motion with the same type of palm wheels that are going to be very familiar to us 3D printer owners, such as the Sovol SV07 and 7 Plus. We'll take a closer look at all these components in just a bit as we assemble everything, because with this we've concluded the unboxing. I will follow the steps in the user manual starting on page 7 for the assembly. So, step 1, according to the booklet, is to connect the front X and Y axes, which was a bit tricky because of the tiny graphics in the booklet. Basically, we need the 2 longer extrusions and one of the shorter ones with the ruler marks on it. That goes in the front. The side extrusions go short side up, the left side showing the ruler, and the front X extrusion, also with its ruler marks, showing on the top. Now it's best to sort the included screws by size. You will need the second longest ones, the M530s, to fasten these 3 extrusions together. So we use a pair of M530 screws on either side to secure them together. In step 2, before adding the other X extrusion in the back, they instruct us to slide in the gantry by rolling the V-slot wheels onto the Y-axis frame. The side with the cable goes on the left side where the ruler markings are. Then, in step 3, we fasten the 4th piece of the frame, also flat side up, using the remaining 2 pairs of M530s. The included full-size screwdriver is pretty good, but an electric one is still recommended. In step 4, we add the 4 stands on the corners. There are 2 pairs. The official video has good close-up of their correct orientation. You will need to use 3 of the M5/8 screws for each corner. Those are the shortest of the screws. They have included 12 of them plus a spare. Now I found these sheet metal stands very lacking. I don't see how the self-adhesive rubber feet that was included could or should be attached to these, but they are super slippery without, and they also scratch up my table. But here comes the benefit of having 3D printers around and some design skills. I quickly designed these little slippers for the stands, which not only stop them from scratching up my table, but also secure the laser cutter to the table so it doesn't move around. I printed the prototypes out of PLA, but then used my super flexible red TPE for the final version. I published these STLs in my Cults 3D account, though they are quite specific to the size of my table, but maybe you can adjust the step versions to fit your needs. We are not there yet, however. We've just fastened the 4 stands in the corners of the frame. Each stand is held by 1 screw on the outside of the Y frames and 3 more screws on the side of the X frames, but you shouldn't fasten the top one on this side yet. You'll see why in a minute. There were some problems with these screw holes though. 2 of the screws did not go in, their threads were stripped. It would probably be easy to fix, but since they don't seem to be crucial, I just left these 2 screws out. Step 5, according to the booklet, will have us install the timing belts for the Y motion. But I skipped ahead to step 6 instead and installed the controller box first. I think it makes more sense in this order. It's held by the 3 longest M540 screws. Let me take the opportunity to give you a little tour of this control box. From left to right on the top, we have the power, USB, micro SD card slot, and an RJ45 style screen connection, emergency light, stop button that you rotate to unlock, and the power switch. On the side, 4 extension ports with constant 24 volt output for LED and exhaust fan, power for air assist pump controlled via M7 and M9 commands, and the safety door sensor. On the front, we have the child security lock with keys and a reset button. On the inside, the sensor and switch for the flame detector, which turned out to be unreliable, so I keep it off to avoid ruining jobs. Finally, the Wi-Fi antenna at the bottom is for mobile connection. We will revisit it a bit later. The website mentions a tilt alarm, but I wasn't able to trip it, no matter how I tilted the device. Everyone in the room should wear safety glasses when the device is active. With the controller box in place, let's advance to step 5, installing the Y-axis belts. Thread them between the top palm wheels and the pulley, with their teeth facing the pulley. The belt runs in the V-slot, teeth facing down, and through the holes at the end of the extrusions. Make sure the moving gantry is perfectly parallel to the front and back of the frame, and pull the belt's ends through the holes. We are using the third M58 screws with washers to fix the ends of the belts. Do not cut the ends, so you can adjust the belt tensions later. My 3D printing background caught up with me once again, and I also checked the palm wheel tightness. They felt a bit loose. The carriage had too much of a wobble, so I adjusted the eccentric nuts on the bottom wheels to bring the wheels closer to the V-slots. They are the correct distance if you can still rotate them, but with a little bit of force. Having step 6 already taken care of, in step 7, we next install the laser module. This is super easy. Just slide it in its carriage from the top and fasten the 2 knobs holding it. Then we can connect the electrical cable and the air pump tube on its top. Push down on the locking ring when inserting the tube. In step 8, the air pump should be placed on the left side of the device. Mine had a plug in its air outlet, which I had to remove before connecting the rubber air tube leading to the tool head. The electric cable plugs go into the port marked Air Assist on the control box. According to the official website, this pump can provide a maximum airflow of 30 liters per minute, but its power cable also provides speed control with an off position. Time to unpack our honeycomb bed. I received the 440 by 440 variant. The 650 version would match the work area better. Be sure to remove the protective film from the aluminum desk protector. I used the corner caps to secure this bottom tray to the frame of the bed. A set of adhesive rubber feet was included in the package. I stuck 4 of them on the corner caps and 1 in the center to stop the honeycomb bed from sliding around on the table. While I was filming the assembly process, a package of 4mm plywood sheets were delivered, which I'll use for my initial projects. As outlined in step 9 in the booklet, I set the focus distance to the work object using the little lever or focusing bar on the side of the laser module. This Z-axis adjustment for focusing provides a range of about 130 millimeters relative to the height of the gantry. Make sure the security lock is unlocked and the emergency button is released before turning the device on. Yes, the tool head cooling fan is pretty loud. You won't want to keep this thing on when it's not working. I installed the free Laser GRBL software on my computer, and it connected without a hitch after plugging in the included USB cable. If it doesn't, double check the emergency button, and on older computers, you might need to manually install the USB driver. Laser GRBL has a dedicated menu command to help you with this. After homing, I was happy to see all motors and limit switches worked correctly. I did a quick engraving test and a few cutting tests to come up with the correct values for speed and power. With my little cousin, you know from my 3D printing videos, we decorated and cut a pair of pencil holder boxes using boxes.py. A great resource. I put the link in the description. I think both our Star Wars and the Naruto designs turned out exceptionally well for a first project especially. I will talk about these and more in a next video. I also cut a large map puzzle out of this 3mm thick plastic sheet. It was super smelly, brutal. Until I find a good enclosure solution, I will only operate this laser cutter on my porch. Air Assist really makes cutting cleaner. If plugged into the designated Air Assist connector, Air Assist can be software controlled via the M7 on and M9 off commands. But if we plug the Air Assist pump into the identical looking 24 volt LED light header, which provides a constant 24 volts, we can manually control the pump using the switch on its cable. Eventually, I found a way to engrave and cut in a single project using Laser GRBL, also switching Air Assist on or off as necessary between the passes. I will talk about this and my initial experience with Lightburn in a future dedicated video. Finally, I tested the Wi-Fi capabilities of the MacPow X5 and the recommended Android app. Well, I'm not blown away by either. For now, I will just stick with wired connectivity and my PC. What do I think of the MacPow X5? This being my very first full-size high-power laser cutter engraver, I can only give my first impressions, which are very positive. I love the lightning fast delivery and very budget-friendly price from geekbuying.com. The ease of assembly, the seemingly unlimited work area size, the solid motion system, especially the linear rail on the x-axis, the reasonably high-power diode laser with its fine laser spot for precision engraving, the inclusion of this controllable Air Assist pump for soot-free cutting, the variety of extension ports on the control box, the gift honeycomb bed, and all the built-in safety features, which all in combination provide relatively high speeds and quality results. I found only a few things that could use some improvement. The four legs or stands on the corners of the frame did need the 3D printed upgrades I designed. The two stripped screw holes will need fixing, but fortunately they are in redundant locations. The included Android software is very basic, and Laser GRBL, though functional, requires you to quickly purchase a license for a more capable software like Lightburn. But this engraver is compatible with Lightburn. If you're already thinking about getting into laser cutting and engraving, as I was, I can wholeheartedly recommend the MacPow X5 from geekbuying.com. I've put links in the description, including coupon codes, which should help you get it even at better prices. Geekbuying.com also has great 3D printer accessories and materials. I recommend looking around. After this quick visit to lasers, I already have my next 3D printing video in preparation about the Sovol SV08. We've utilized the large print volume for a special race car part. I will talk about all the considerations and the experience gathered in this project. I'm happy to hear some of you are already starting to receive your SV08s. We will tune Orca Slicer to work perfectly with this fantastic 3D printer. Check out my 3D printing videos here, my review of the tiny K10 engraver here, or, how do we say it? Go Print 3D. Thank you for supporting Ergo Print 3D with all your likes, comments, and subscriptions.